Hello students, welcome to Eshwari Taniksha channel. Students, in this video we are going to learn the meaning of equilibrium, its characteristics and also equilibrium in physical and chemical process. So first let us understand the meaning of equilibrium. So take a stone, apply force in this direction. So stone will start moving in this direction. In another example, so this is the stone, apply force in this direction, stone will start moving in this direction. In another example, this is the stone, you are applying force in both the direction. It should be equal force. Equal force you are applying in both the direction. So what happens to the position of the stone? Position will remain constant. It will not move in any direction. Why? It is because the net force acting on it becomes equal to 0. So this condition is called as equilibrium condition. So equilibrium means the position remains constant. It is not moving in either of the direction. So here it is called as static equilibrium. Static equilibrium. In chemistry, we learn another type of equilibrium which is called as dynamic equilibrium. So let us learn this by taking one example. So students, take a box. Inside the box, we are placing 3 balls. 1, 2, 3. So now initially I'll ask you to count the number of balls. So you will count and you will say there are 3 balls inside the box. And there is a opening to this box. Here one opening and here one opening. So now we will send one red color ball inside the box. At the same time we will remove this blue color ball. So now this red ball has entered and this is another ball, second ball. This is the first one and this ball has come out. So now these are the balls present. Now I'll ask you to count the number of balls. You will count 1, 2, 3 and you will say there are 3 balls. So the number of balls are remaining constant. So constant means it is equilibrium. Dynamic meaning is keeps on changing. What is changing here is the type of balls are keeps on changing. Blue color balls, 1 red and 2 blue balls. So the types are changing but the number is remaining constant. Why the type of balls are changing? Because we are sending red ball inside and blue ball is going out. Because of this continuous process, the type of balls are changing. So this is an example for dynamic equilibrium. So students, now we will learn 2 important types of reaction. One is called as reversible reaction. Second is irreversible reaction. Irreversible reaction. So first let us study reversible reaction. So in a reversible reaction, A will convert to B. That is, reactant will convert to product and product will convert to reactant. So product will again convert to reactant. So reaction is taking place in 2 directions. That is forward direction as well as backward direction. So now this you can represent like this. So this is a reversible reaction where forward reaction as well as backward reaction takes place. Backward reaction takes place. And students, if we represent a graph, this is the graph, this is time, and here we will take concentration of the reactant. Concentration of the reactant. So initially the concentration of A will be high because we are taking only reactant initially, product will be 0. So slowly what will happen as the reaction proceeds, concentration of A will slowly decrease and it will become constant. So in a reversible reaction, the concentration of the reactant will never become equal to 0. This is the conclusion we are getting. So I'll write concentration of the reactant will never become equal to 0. It becomes constant in reversible reaction. And next point is reversible reaction always takes place in closed vessel. So let us take a closed vessel. Here A will convert to product B. So B will again convert back to reactant. So reversible reaction can take place only in closed vessel. If it is open vessel, then the product will escape. So again backward reaction will not take place. That is why it should take place in closed vessel. Next is irreversible reaction. So in irreversible reaction, reaction always proceeds in only one direction. Only one direction. For example, take hydrochloric acid, which is a strong acid, react with base sodium hydroxide. It will form NaCl and water. So at a particular condition, so only this reaction will take place. So if you dissolve salt in water, you will not get back this hydrochloric acid and sodium hydroxide. So the reaction proceeds in only one direction. This is irreversible reaction. So if you draw a graph, time and concentration of the reactant on y-axis. So this is concentration of reactant. So initially it will be more, slowly it will decrease and then it will become 0 at one point. So in irreversible reaction, the concentration of A will become equal to 0. And irreversible reaction takes place in open vessel. Open vessel. That is, we are taking a beaker. So in this, take water molecule and you start heating it. So it will be converted into vapor and it will escape. So again it will not react and it will not form the reactant. So this is called as irreversible reaction. So now let us learn the characteristics of equilibrium. Characteristics of equilibrium. So the first characteristic is, you can see equilibrium only in reversible reaction, and you know that reversible reaction takes place in closed vessel. So this is the first characteristics. Second is, the rate of forward reaction is equal to the rate of backward reaction. So students, at equilibrium you can see the rate of forward reaction will be equal to the rate of backward reaction. For example, if you take a reaction A forming B. So here you can write the rate of forward reaction is directly proportional to concentration of the reactant, and rate of backward reaction is directly proportional to concentration of the product. So students, now we will draw the graph and we will try to understand this. Here the meaning of rate is speed. Speed of forward reaction should be equal to speed of backward reaction. So draw three graphs, 1, 2, 3. So you take rate on y-axis and time on x-axis. So rate and time. So now the rate of forward reaction. So rate of forward reaction is directly proportional to concentration of the reactant. Initially the concentration of the reactant will be more. So here we will write the rate of forward reaction, RF. So the rate of forward reaction will decrease slowly like this, and then it will become constant. Rate of backward reaction, slowly it will increase and then it will become constant. In another graph, this is rate of forward reaction, slowly it will decrease and then it will become constant. Rate of backward reaction, it will increase like this and then it will become constant. Another graph, rate of forward reaction, it will decrease and then it will become constant. Backward reaction, it will increase and then it will become constant. So now let us check which graph is correct for this. Rate of forward reaction is equal to rate of backward reaction at equilibrium. We are checking equilibrium. First graph, you see whether the rate is same. Here both the rates are different. This is the rate of backward reaction and this is the rate of forward reaction. Both are different. So this graph you cannot draw. This is wrong. And here the rate of forward reaction is equal to the rate of backward reaction. This is correct. Here also you can see it is not equal. So the rate of forward reaction is equal to the rate of backward reaction at equilibrium. You can draw only this graph. So this is the second characteristics. Next, third characteristic is concentration of reactant and concentration of product remains constant. For example, if you write this reaction, so concentration of A and concentration of B becomes constant at equilibrium. So let us draw the graph. So take concentration in y-axis, time on x-axis. So first graph for the reactant. So this is for the reactant. So initially the concentration of the reactant will decrease and then it will become constant. And for the product, it will increase and then it will become constant. Another graph, reactant will decrease and it will become constant. Product is increasing and then it will become constant. Reactant will decrease and then it will become constant. Product, it will increase and then becoming constant. So students, you can see here what we have written is concentration of reactant and product should become constant. So you can see here concentration of reactant and product is becoming constant. So this is equilibrium. So this graph is correct because concentration is constant. And here you see from here the concentration is becoming constant. So we are saying constant and we are not saying it as equal. It should not become equal. It should become constant. It can become equal or it should remain constant. So constant meaning is same value it should get. So here you can see it is becoming constant. So you can draw even this graph. And from here you can see this is the equilibrium. You are getting a straight line here. So this is the straight line. So here again concentration of the reactant and product is becoming constant. So you can draw even this graph. So only the difference is here it should become equal, whereas here it should become constant. So here in all the three cases you can see the reactant and product is becoming constant. Fourth is at equilibrium you can see concentration and pressure becomes constant. This is another characteristics of equilibrium. And next point is equilibrium can be detected by concentration, pressure and change in color. So meaning is a reaction will be taking place. So you have to check whether the reaction has attained equilibrium. So what you should see is you have to check the concentration. If the concentration has become constant, then you can say that equilibrium is reached. Or if pressure becomes constant, then you can say the system has attained equilibrium. Or if you see change in color, so if you get a constant color, then you can say the system has attained equilibrium. So these are the characteristics of equilibrium. So now let us learn equilibrium in physical and chemical process. So first is equilibrium in physical process. So equilibrium in physical process. So here physical process means there will be change in phase. Change in phase. So students, you know that there are three phases. One is solid, liquid and then gas. So if there is change in the phase, then it is a physical process. For example, solid changing to liquid. Second is liquid changing to gas or vapor. And third is solid changing to vapor or gas. So these are the three changes we are going to learn. So first we will take solid liquid equilibrium. First is solid liquid equilibrium. So let us learn this by taking one example. So here the example what we are taking is water in the solid form converting to water in the liquid form. So here water in the solid is nothing but ice. So now take a thermoflask. So this is the thermoflask. Inside the thermoflask we are going to take ice. So this is the concentration of ice. And then take water. So this is water and this is ice. So now the temperature is maintained at 0 degrees Celsius and pressure is maintained at 1 atmosphere. So now what will happen is at time is T is equal to 0, you measure the concentration. So concentration of ice will be this much and concentration of water will be this. And after 1 hour you observe the concentration. So concentration again it will be the same, there is no change. After 2 hours you check. So after 2 hours if you check, again it will remain the same. So why the concentration is remaining same here? Because concentration remains same because some of the ice is getting converted into water and some of the water molecule is getting converted into ice at equilibrium. That is the reason. Equilibrium. So you know that at equilibrium concentration is going to remain constant. So that is why when some ice is getting converted into water, water will get converted into ice. So the temperature and pressure should be kept constant for that. So second example is liquid, so liquid to vapor equilibrium. So let us learn by taking the example. So this is the example which is given in the textbook. So students, here you can see we have taken a closed container. Inside the closed container, we have taken anhydrous calcium chloride in a watch glass. So anhydrous calcium chloride is a white powder. So it has hygroscopic character. Hygroscopic meaning is it absorbs water molecule. So if any water molecule is present inside the container, it will start absorbing all the water molecules. So once it absorbs all the water molecule, we will remove this anhydrous calcium chloride, and next we are going to place our beaker containing water. This is at time t is equal to 0. We are keeping beaker containing water, and this is the level of water. And we have connected here U tube. Inside the U tube there is mercury. So initially you can see the level of mercury remains the same. So when we keep water at time t is equal to 0, there is no reaction, and here the level of mercury remains the same. After some time, what happens is, here the water molecule which is present, due to evaporation, it will get converted into vapor. So now you can see the level of water. The level of water has decreased because it is converted into vapor by evaporation. So now this will start moving in all the directions, and it will exert pressure. Because it is exerting pressure on the mercury, the level of mercury changes. So here it will decrease and here it will increase. And then you can see slowly what will happen is, some of the gas molecules will lose energy and it will condense, and then it will be converted into water. So now next what happens is, at equilibrium the rate of evaporation will become equal to the rate of condensation. Rate of evaporation becomes equal to rate of condensation. So here in this step evaporation takes place, and here condensation is taking place, and here the rate of evaporation becomes equal to the rate of condensation. So that is why the number of molecules will remain same here. The number of gas molecules remain same. Therefore, pressure becomes constant. Pressure will become constant. So students, the pressure which is exerted by gas molecules here is called as vapor pressure of water. So here this is called as vapor pressure of water molecules. So the pressure which is exerted by water vapor is called as vapor pressure of water molecule. So here, because the pressure is remaining constant, you can see here the level of mercury level, it becomes constant. So here the temperature we have to maintain constant when we are carrying out this experiment. So here the temperature is maintained at 100 degrees Celsius and pressure is maintained at 1 atmosphere. So this is the experiment which is explained. This is the example which is given in your textbook. So next we will go for third phase. So third one, solid vapor equilibrium. So example we can take iodine. Iodine in the solid form converting to iodine in the gaseous form. So students, now take a closed container. So inside the closed container, we are taking iodine crystals. So these are iodine crystals, means in the solid form. So when you supply small amount of heat, what happens is it will directly convert to gas. And you can see violet color. So violet color you can see here. So when the violet color becomes constant, slowly the color will intensify and then it will become constant. So then we can say that equilibrium is established. So I told you how to detect equilibrium in a reaction. You can detect when concentration becomes constant, equilibrium is attained, or when pressure becomes constant, or when the color changes and it becomes constant, we can say that equilibrium is attained. So this is about physical process, equilibrium in physical process. So next we will study equilibrium in chemical process. Equilibrium in chemical process. So chemical process means breaking of already existing bond and formation of the new bond is called as chemical process. For example, N2 plus 3H2, it gives 2NH3. So here already existing bond between nitrogen and nitrogen will break and new bond will be formed between nitrogen and hydrogen. So graphically, if you want to represent this, take concentration on y-axis and time on x-axis. So now you can see nitrogen and hydrogen is in the ratio 1:3. So take nitrogen concentration, this is nitrogen, and hydrogen concentration will be this. This is for nitrogen and this is for hydrogen. And initially concentration of ammonia will be 0. This is ammonia. So concentration of the reactant will slowly decrease and then it will become constant. So decrease and it will become constant. Product concentration will increase slowly and then it will become constant. So this is the representation of equilibrium in chemical process. So here how to check where equilibrium is established, where the concentration becomes constant. So here you can see straight line from here. So this is equilibrium. So this is equilibrium in chemical process. So students, I'll meet you in the next video.